Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we are going to start learning about surface area of prisms. This chapter entails surface area of prisms and volume as well of prisms and of pyramids, cylinders, cones. Very, very easy stuff actually, but you have to remember several things for this chapter. You got to remember some basic trig. You've got to remember your 30, 60, 90 and your 45, 45, 90 triangles. You have to remember the formula of regular polygons, squares, trapezoids, triangles. So you must know your regular area formulas as well. So it's a lot of stuff bundled up together. So without any further ado, solids with flat faces, okay, are called polyhedras. Okay? So all of these here in front of you are polyhedras. So when you're playing a game and you roll dice, that's a cube, but it's made up of flat faces, so that would be considered a polyhedra. Okay? Any 3D figure basically with flat faces is a polyhedra. Pyramids, any type of prism, these are all polyhedras. Now, one familiar type of polyhedra is the prism. Every prism has two congruent parallel faces called bases, okay? And a set of parallel edges that connect corresponding vertices to the two parallel faces. The parallel edges joining the vertices of the bases are called lateral edges. The faces of the prism that are not bases are called lateral faces. The lateral faces of all prisms are parallelograms. Therefore, we name prisms by their bases. And a prism with a hexagonal base, for example, is called a hexagonal prism. Okay, I have some examples that I'm going to pass around that you can actually touch, but let me just go over this right now and then I'll hit pause. If you can see here, guys, you recognize a prism by finding two identical bases, okay? Two identical bases. So in this particular case here, in this rectangular prism, I've got this right here and this guy right here. I am choosing to make my bases because they're parallel to each other and they're congruent. Okay? Let me show you this in real life. Okay, so now that you see them in real life, let's talk about the other pieces of prisms. Okay? Let's use a different color. The line that connects one vertex of the base to the other vertex of the base, that's called a lateral edge. Okay? And the actual face that is not part of the base is called a lateral face. Okay? This is very important, guys, to recognize all the pieces here. Then I showed you a couple other types of prisms. There are an infinite number of prisms. This guy right here would be a hexagonal prism. Why is it a hexagonal prism? Because I have not one, but two hexagons that happen to be parallel to each other and congruent to each other. That makes a prism. This guy down here is a pentagonal prism. Why is it a pentagonal prism? Because it has two bases that are pentagons that are parallel to each other and congruent to each other. Does this make sense? But for real, guys, does this make sense? Gotta know how to recognize parallel bases that create these prisms. Make sense? All right. Now, what is surface area? Surface area, guys, in a nutshell, is the area of all of the faces and bases combined. Surface area is the sum of the areas of all faces of a polyhedron. It's the area of every single face, both the bases and the lateral faces. Okay? Everything. So if we look at it from a dissection point of view, if I have this rectangular prism, okay, think of a box, and I start popping out all the sides, okay, this top, this is a top, these guys here are the sides, these guys here are the sides, this is the base, okay, this is another lateral edge aside, and this will be the opposite of the base. So if I pop it out, I create 6 different rectangles. If I take this triangular prism and I start popping out all the sides, okay, the 2 triangles, which would be the bases, are right here. And then I have the 3 sides laid out, though, in a 2x2 format, in a linear format. It's not 3D anymore. So if I wanted to, and I wanted to make my life difficult, I could literally look at a prism, pop out all the sides, draw out, it's called a mapping of the prism, and I can find the area of each individual side. Totally can do that. Would I recommend that? Absolutely not. Because it's kind of difficult sometimes to see the mapping of a prism, especially when we get a little bit more complex. But I need you to understand here, basically, is recognizing the 2 bases. In this case, this guy and this guy could be the bases. So I pop those out to the side right here. And the rest in here in the middle are the lateral edges. Here, I have 2 congruent parallel triangles. That's these 2 guys. Those would be the bases. So again, you want to break it up and go one by one and find the area of each side. Have at it. I definitely would not suggest that, though. I would suggest a much better way, which is using a formula. Now, this formula is very powerful because it will solve the surface area or find the surface area for any prism. Period. Any prism. Triangular prism, hexagonal prism, octagonal prism, okay? Pentagonal prism. Does not matter the base or the type of prism. And it's S, which I don't really like that. So we're going to change that to SA. Let's make that surface area. I'm going to change that to surface area. I like that better. Surface area equals 2B plus LA. Now, LA, no, not the city. Not Los Angeles. It's called the lateral area. And that big B is called the base area. Okay? Let's look at the formula here and understand it before just using it. 2B means that I have 2 bases. That makes sense. Because in the prism I just told you, you're going to have 2 identical bases that are parallel and congruent to each other. So we're going to find the base of whatever prism we're given, and we're going to multiply it by 2. So that takes care of our 2B here. Remember what I told you at the beginning of this lesson. You're going to have to be able to find the area of any base they give you. So that's why you need to remember the formulas for all the different types of polygons that are out there. Because I may give you a trapezoidal prism. You have to find the base area, which would be the area of a trapezoid. I may give you an octagonal prism. And then you have to go ahead and find the central angle. You got to drop the apothem. and then use the formula area equals apothem times perimeter divided by 2. So you have to remember those formulas. So if you don't, I suggest you remind yourself. Now this LA, what is this LA? It's the lateral surface area. Remember that we have lateral edges that connect one base to another base. We also have lateral faces that are surrounding the bases. And the lateral area is literally the sum of the areas of the lateral faces. Now, does that mean that I have to add up all of the areas of the faces? No. It's very easy to find the lateral area because it's the perimeter of the base times the height of the figure. It's the perimeter of the base times the height of the figure. Now, you may be thinking to yourself, okay, how does that make sense? Well, let's think about it, guys. For those of you in the internet world, you can't really see what I'm doing here, but just try to listen to me clearly. Okay, I have here in front of you, I'm showing you guys a hexagonal prism, correct? So you know you have two bases that are hexagons, right? That's my 2b of the formula. Everyone gets that part, right? Okay. Now, what's the area of a rectangle? Base times height, correct? Okay. What are each of these lateral faces? Aren't they all rectangles? Okay. So what I'm doing is I'm taking the perimeter of the base. Basically, the perimeter, remember, is the sum of all sides, right? And I'm multiplying it times the height. So it's like taking this little side times height, plus this little side times height, plus this little side times height. I could do that for all of them and have 6 different rectangles and add them up. Or I can say to myself, wait a second. What's the perimeter of the base times the height? I'm finding the sum of all the rectangular lateral surfaces. Does that make sense, guys? Because again, you know me, I don't like to just say, this is the formula, use it, too bad. I want you to understand where this formula is coming from because it's going to make you much more of a powerful problem solver for this. So does that make sense? So I've got to find the surface area of any prism, 2 times base area times lateral height, which is perimeter of the base times height. Yes, sir, my brother. Can you do base times height times the number of sides? No. No. Thank you though for asking. That would if you look at the logic there, you'd be adding another multiplication to it. Okay? What you could do is you could say, okay, what is the side of each, what is the value of each side of the base? And then multiply each one of those times the height and then add them all together. But that's just too time consuming, okay? So, for example 1, I want to find the lateral area and then I want to find, sometimes they tell you total area. If they ask for total area, please know it's the same thing as surface area, okay? So I want to first find the lateral area. Well, lateral area is perimeter times height. I always have to recognize my base here. Which is the base here? Yeah, the triangles are the bases. Very good. Triangles are the bases. Okay, so what is the perimeter of this triangle? Remember at this 15, I'm throwing you off. That 15 is the same thing over here. Correct, you add up all the sides. So you got 27 plus 15, 42. So my lateral area equals 42 times, what's the height of this prism? 20. Okay. Thank you. Thank you for saying that. My boy just said the height of the prism is 12, Mr. Morrow. No. The height of the prism is the lateral edge that connects one base to the other. Okay? Think about it. Right here. Again, I'm showing you right now in front of you. a triangular prism. The height of the prism is not the height of the triangle. The height of the prism, check it out, Bubba, is from base to base. So the height of the prism, great mistake, by the way, I'm very proud of you. The height of the prism, again, is the distance from the vertex of the base to the other base. So I've got 42, which is the perimeter, times height, which is 20. Okay? And that's going to equal 840. Now find the total area. Well, surface area equals 2b plus lateral area. The base area here is 12 times 14 divided by 2. So that's going to be 84, but times 2. So that's going to be 168 plus 840. My surface area here is 1,008 units squared. Yes, sir, my brother. Okay, thank you very much. How did I get 168 was the question. The base area here is a triangle. Area of a triangle is base times height divided by 2. Correct? So that goes to 7. So my base area is 84. But aren't there 2 bases? Okay, not being sarcastic, but that's why we have 2b here. So 2 times 84 is 168. So it's 2 times the base area plus my lateral area. And in this case, it would be 1,008. Does that make sense, guys? Talk to me. You got it? Okay. 12-2. Now we're going to talk about pyramids, guys. Don't worry, you can handle it. It's all good. A pyramid, my friends, is different than a prism, hence a different name. A pyramid has only one base. That's the difference. Prism has 2 bases. They're parallel from each other and they're congruent. A pyramid sits on its base. It's a lot easier to recognize, in my opinion, a pyramid because it only has one base upon which it sits on. Okay? Kind of like the pyramids in Giza, in Egypt. They sit on one base. And a pyramid has lateral edges, but they are not parallel. But they do meet at a single point called the vertex. And the base may be any type of polygon, but the lateral faces this time will always be triangles. So the lateral faces of a prism are always rectangles. The lateral faces of a pyramid will always be triangles. Pyramids are named solely by its base. So you have a rectangular pyramid because you have a rectangular base. You have a hexagonal pyramid because you have a hexagonal base. A heptagonal pyramid because you have a 7-sided polygon, a heptagonal right here base. You have a decagonal pyramid. That means there's 10 sides. That means there's 10 little triangles that create the faces of this pyramid. Okay, let me show you this in real life as well. Okay, so hopefully you can see clearly the difference between a pyramid and a prism. Now, a regular pyramid has a regular polygon as its base and also has congruent lateral edges. Thus, the lateral faces of a regular pyramid are congruent isosceles triangles. When we look at a pyramid here, guys, okay, there's a few things that I need you to really understand because the formula is a little bit more detailed than the formula for the surface area of a prism. A pyramid has what's called an apex or a vertex. This is the point that all lateral edges go to, or where all lateral edges intersect. You have a base upon which the pyramid lies. And every single face of the pyramid is a triangle. If the base of the pyramid is a regular polygon, all of those triangles all of those lateral faces, triangles, are regular isosceles triangles. That means that not regular, I'm sorry, congruent isosceles triangles. The height of a pyramid is the height from base to apex or vertex. And then there's another part here. It's called the slant height. The slant height is the height of the triangular lateral face. Huge stuff here, guys. Got to know your stuff here. You got to remember the Pythagorean theorem here as well. Why? Let me explain. Let's look at this square pyramid here. I know at the top here is my apex or vertex. Okay? My altitude, that's the height from vertex to base. You have my base right here. And then you have the slant height. The slant height, again, is the height of the actual face of the pyramid. You with me here? Okay. If I want to find the slant height, let's look at this hexagonal pyramid right here. I have an altitude here. Can't I just cut across here, and didn't I create a right triangle? So then I can find my slant height by using the Pythagorean theorem. Okay? Yes, sir. Does this make sense, guys? So altitude and slant height are completely different. Altitude is the height from vertex to base. Slant height is the height of the triangles that make up the lateral faces. You with me here? Okay. So now the surface area of any pyramid, that's the beautiful thing here, of any pyramid is 1/2 of slant height times perimeter plus base area. So the big B, the capital B, is the base area. Okay? P is the base perimeter. And SH is your slant height. So the surface area, which again I should put SA. Whoa. The surface area of any pyramid, that's the beautiful thing about these equations. It's any pyramid is 1/2 of slant height times perimeter plus the base area. Now this happens if and only if I have a regular pyramid. That means that the base is a regular polygon. When the sides are different, the area will change. The surface area will change. If I do not have a regular polygon base, the surface area will be the base area plus the lateral area, which is the sum of all lateral face areas. Yes, sir?
So for all pyramids
Correct. Not all pyramids will have a regular base, so therefore not all lateral faces will be congruent when you have different, when you have a non-regular base. Okay? So different formula. And remember what the lateral area is. It's perimeter times height. Okay? You guys with me here? Yes, no, maybe kind of, sort of? All right. Let's do this. Example 1. Given a regular pyramid. So we know that the base is regular here. Okay? It's a regular pyramid. I want you to find the lateral area, and then I want you to find the total area. All right. Well, the lateral area would be what here? Okay. Do we have the height? No, we don't. Okay. I need to find this height here. Okay. I need to find this height here. Okay. You could do several different things. Well, I have the height of, yeah. I'm gonna have to first find my slant height before I find my regular height. Yes, sir. We'll do it in a different color. Correct. No, well, it's a 3, 4, 5. No, it's not a 3, 4, 5. Look, check it out. Check it out. And yes, you were right. Let's go over here. Let's do this slant height here. I know that this is 6, correct? Because it's half of this base, right? And I know that this is 10. Oh, okay. How about this? I'm doing it the wrong way. My bad. Let's do it this way. This is 10. We know that, right? Half of this is 6, correct? So what's my slant height? 100 equals 36 plus slant height. Yeah, this is a 3, 4, 5 times 2. Yes, so that's 8. Very good. So that's 8. I still need to find my altitude, though. So now this is 6, and this is 8, my slant height. What's my regular height? It's not a 3, 4, 5 triangle here. It's 64 equals 36 plus my height or altitude squared. So 64 minus 36, what's that, 28? 28 equals h squared, square root both sides. My height equals 4 times 7, which is 2 square root of 7. So my lateral area, which equals perimeter times height, will equal 12 times 4, which is 48, times 2 square root of 7. So that's 96 square root of 7. So does everyone see how I got that? And if not, that's why I'm a teacher. I'm here to help you guys. But it's very important that you understand how I got everything there, guys. Yes, sir. Come again, my brother? Okay. The perimeter of the base is what? 12 times 4, correct? And what's 12 times 4? 48, right? What's 48 times 2? 96 square root of 7. Does that make sense? You with me here? Yes? No? Maybe? Kind of? Sort of? Okay. Not really? Okay. Okay. All right, guys. Thoroughly embarrassed here. This is all wrong. My slant height is correct. Okay. This is 6. This is 10. That's 8. That is correct. My slant height is 8. However, Mr. Morrow is not paying attention. The lateral area of a prism is perimeter times height because they're all rectangles. Maybe Mr. Morrow should learn how to pay attention. The lateral area here is, since it's a regular polygon, the sum of all the areas of each face. Wow, I'm so embarrassed. So what is the area of each face here? It's a triangle. So the triangle area of each face here is 12 times 8 divided by 2, right? So each area of each lateral face here is 48. How many faces do I have? What's 4 times 48? That'd be 192. That's my lateral area. Wow. That was embarrassing. Times 4 because there are four triangles, 4 lateral faces. Wow, that was really embarrassing. Sorry. My bad. My bad. Okay. Yeah, that was pretty bad. Now, what is my total area? Well, I have my base plus my lateral area. My base here is 12 times 12, which is 144, plus my lateral area of 192, and that gives me 336 units squared. So I'm sorry about that. Digest it. Ask me questions. That was completely my bad. I kind of feel really embarrassed about that. Sorry about that. Does that make sense, guys? Okay. Let's do an example now. Another example. The base of a rectangular pyramid ABCDE is 10 by 18. The altitude is 12. The lateral edges are congruent. Why is ABCD not a regular polygon, pyramid? So if look at what the base here. The base is 10 by 18. So is that a regular polygon? No. Why? Why is it not regular? Because the sides are not equal. Okay? So what's happening here? This guy's 18. This guy's 10. Right? It says my altitude is 12. So let's go ahead and make an altitude here. Kind of clutch, right? Let's make an altitude. That's right. I had pre-made this. Yes. It's my altitude of 12. This is my this guy here is my slant height. Can make a slant height over here as well.
So the slant height makes a 90-degree angle, right?
The slant height makes a 90-degree angle with this guy right here, with the face. Okay? You with me here, guys? So I want to find the pyramid's total area, or the surface area. So what would I do here in this particular case? What's the formula? Base plus lateral area. Correct? Okay, so what's the base? So surface area was base plus lateral area. What's the base here? 18 times 10, which is 180. Now, plus the lateral area. Okay, let's check this out here, guys. I put two slant heights here on purpose because I'm going to have two different areas for the lateral faces. So this first triangle here, okay, what is my slant height for that particular face? Very good, son. How is it 13? Well, he knows that my altitude is 12 here. Half of the base is 5. So my slant height here is 13. So what is the area of that particular lateral edge? Now, 13 times 9, right? Because it's 13 times 8, because I'm trying to find this triangle. So it's base times height, 18 times 3, divided by 2. So 9 times 13 is 117. But times 2, right? Because there's 2 of those. So 2 times 117 plus. Now let's look at this guy. What is the slant height for that bad boy? Well, I know that my altitude is 12. This base here is 9. So isn't this a 3, 4, 5 times 3? So this would be 15. So now, what is the area of this triangle? The base is 10. 10 times 15 divided by 2. So that's 5 times 15, which is 75, but there's 2 of those. So my total area here will be 180 plus 234 plus 150. So that's, what is that? That's 330 in total? 384? No. No. You got 180 plus 150, which is 330. 330 plus 234 is 564 units squared. Okay, if you're lost, tell me why. Thank you. Hold on, boys. 12 times 3. Okay. 18 base times height of 13 divided by 2. 9 times 13 is 217. And there's 2 of those faces. Yes, sir. Okay. Isn't this whole side 10? So isn't half of it 5? I was finding, okay. Check it out. I know that my height is 12, correct? But from this center point to this edge here, isn't that half of this side, which is 5? So that's a 5, 12, 13, making that my slant height. Does that make sense? All right, guys. You've got your work cut out for you. This is not just a formula you plug in. There is work that you have to do to it. But I know you can do it. I believe in you. Thank you for a good lesson. Hope you learned a lot, and have a great day.